Hi everybody, welcome to Beyond the Bench, where we discuss taking hardware through production and the stories along the way. My name is Bill Brock, CEO of Peridio, the ecosystem for building and maintaining advanced embedded products. Hey everybody, welcome to Beyond the Bench, Hardware Stories That Matter. I have a really exciting guest for you all here today, Mike Costa from Volta Labs. Hey Mike, thanks for joining the show.
Hey Bill, how's it going? Thanks a lot for having me.
Yeah, absolutely. So I met you probably just over a year ago through some colleagues that worked together. Actually, no, I met you through Jordan, who worked with you at, where were you and Jordan working together? Was that Nike?
Yeah, that was when we worked together back at Nike Digital Sport when that group was in full force back in 2012, 2013 or so.
And then we also happen to have half a dozen mutual connections in the Boston area from the SimpliSafe work as well, which is really cool.
Right? Yeah. You have a lot of connections out here in Boston.
I have a few friends. Actually, I got lucky. So the person who replaced me in my previous role, Heath, who I think you worked with, he is my whole Boston network. So grateful for Heath. Making a lot of nice intros there.
Yeah.
Well, so tell us about Volta. What are you guys working on?
So I'm at a company called Volta Labs. Volta Labs we're still in a startup mode, so the company's been around about 6 years or so. We develop a product that helps automate the sample preparation phase for genetic sequencing. So if you imagine when you want to sequence a genome, you'll have DNA, and you'll have to prepare that DNA to go into a specific type of sequencer. So there's different aspects of like getting that DNA prepared. So you might have something like whole blood, and you have to extract the DNA from that blood. You have to do some things like enzymatic fragmentation, which is splitting up the DNA into little chunks, or you have to do something called library preparation. And so the Volta Labs equipment can automate and be the front end for that, and so that you have your DNA prepared and ready for sequencing.
And how did a hardware guy find himself in a genomics company?
I think it's just it's a laboratory device, and so having an embedded background, somebody's got to build these things. The founder is an electrical engineer, so at the end of the day, a lot of the fundamental technology of how this device works is based on some pretty cool tech, and so it's applied in a novel way, but with like a lot of off-the-shelf type of equipment, like things like gantries and pipetters and microfluidics manipulations.
And so how much of the smarts is happening on device versus post-processing in the cloud? Like, where is the actual like rocket science happening?
I would say it's 100% on the device right now. It's kind of I don't want to simplify it, but it is just a machine that kind of takes a sample and it runs through a routine. We call them apps, but it's really just kind of maybe think of it as a biological recipe. So you take blood, and you'll take this enzyme or this reagent or in water, and you mix them together, and then you heat them, and you vibrate them, and you mix them, and you split them apart and repeat and cycle, and out comes DNA. And it's a very straightforward process, and it doesn't and as long as it follows the routine in a very deterministic way, the customer can rely on our ability to output that sample preparation for sequencing.
And so this is being used in your customers' labs?
Yeah. So largely research labs, and so we have a couple of customers that we've been public with. One of them, for example, is Mount Sinai Research in New York City at the hospital. And so they do genetic sequencing in the hospital, and they're using our product to help automate the sample preparation for that sequencing.
There is so much cool work happening in the life sciences space right now. And I know you mentioned you listen to Leaf Labs episodes. They do a lot in this. They're actually in Boston too. If you haven't met them, I should do a quick intro. But it's just really cool to see hardware and AI trending to the physical, like biological area. It's really exciting time.
Yeah, I think just on the topic of AI, I mean, there's so much there's so much more opportunity when it comes to applying both machine learning and AI in some meaningful way to laboratory applications. And I'm really, at this point, we've got a functioning product, and I think the next phase would be to really introduce some of those cool new features that can really like open up a lot of possibilities. Because right now we have a bunch of like super smart biologists, and they come up with the biology recipes, and so that we have what we call like an app menu. And so you could just kind of pick on screen what biological protocol you can run. And we have an awesome team of biologists that help develop those protocols. But I can imagine one day that could be augmented and supported by AI in some way. But we're not quite there yet.
What does an app do? I know nothing of this space, so
yeah. And so what we call it an app, but essentially it's that biological recipe of taking, if your input's going to be blood, or your input is going to be some other biological sample, you have to take that and mix it with certain type of reagents, certain type of enzymes, or certain types of proprietary library preparation packets, and then that goes through a certain sequence of flows of heating, mixing, cooling, splitting, etc. And that's what we call an app. But you can select out of tens or hopefully hundreds one day different apps that will automate all different types of processes, because there's thousands of different recipes out there for what I call recipes. Being an embedded guy, I think the biologists would wouldn't like me calling it that way, but it's a way I like to envision it.
And how often do you get people who used to work at Theranos submitting resumes at this company?
Not too many, fortunately, but it's
West Coast maybe.
Yeah, it's the Boston area has an awesome population of life sciences and engineers, both bioengineers and electrical, embedded, etc. engineers that have been in the medical space. So there's a lot of really great talent out here for this sort of product.
And I think when we first met, or when I saw you in Boston last, you had just started. I think you were like 3 or 4 weeks in, and you were coming on to, I don't want to overstate the role, but it sounded like you were coming on to help with some of the first like physical deployments. And I'm sure that there was a little, they're bringing in the expert. So like, how's the last year gone?
Yeah, it's actually gone great. We, when I started, we were shipping that first instrument that was going to Mount Sinai, which was our first customer, and it was pretty wild. Definitely, as a startup, shipping a product to a customer. We've shipped a bunch more over the last year, and so what I've been doing is just trying to help us scale, help us dial in processes, both help improve it. So I manage the engineering group now, so both electrical, mechanical, and software. So just bringing in some process to kind of help us focus on what's the right thing, what do the customer needs, what are the customer needs, what are the stability improvements that we need to bring, what are the new features that we need to bring in, we'll help prioritize that, right? And building the right team to achieve those. So overall, it's been really great, and we're hoping to hit that hockey stick at some point, right? At some point soon, where slowly you start building up momentum and reputation, and we're slowly getting there.
What are some of like the low hanging fruit when you first come on board? Where you've done a lot of at scale, and I know we maybe mentioned this, but like Nike, Whoop, Shark, SimpliSafe, like those are huge consumer electronics programs, millions of devices, maybe tens of millions that you've had exposure to, but now you're like helping get unit 1 out the door. So how do you think about that? What is like the difference here?
So getting unit 1 out the door is, it's really just making sure it works. So, getting something from that is migrating from research, from a research phase to a robust deployment phase. And so even that one unit needs to work reliably and consistently and frequently. And every time you use it, the customer wants to have trust that it will work. And especially when we have these customers where they're putting a financial investment into a run. So every time they use the product, there is a financial investment because there are these biological samples that go into it. So if something wrong happens, they lose the biological sample, and then they have to like prepare it again, and then eventually they could even run out of the biological sample. So quality and confidence are the top things. And so when I bring my mentality is I've always been a very consumer-centric type of product engineer. Like, I really value what the customer needs, and to me, a big part of that is just quality and trust, and having so bringing that in, just focusing on debugging, bringing it. I brought in an SQA team, or not a team person. So just having a little bit of more focus on shifting the focus from just feature development and getting the thing to work to getting it to work reliably. And so that's much more focus on just like really nailing down, hardening things, using it a lot, pushing the buttons, trying to test the corner bounds of everything, and getting it to that high confidence level.
And what's the mindset shift from having dozens of customers to tens of thousands with like a SimpliSafe or whatever? Like, how you think about customer support, is that very different, or are you on a first name basis with the people at the labs? Like, what's that look like on the customer success side?
Oh yeah, so at Volta, it's very, 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 very tight knit with our customers, because we're constantly asking them, "Hey, how's it going? How's it going? Do you love it? You love it, right?" So it's really, really high touch, really, really white glove kind of service at this point, right? And that's partially to both make sure that they have an outstanding experience, because we want them to be ambassadors for the product, but also because it is early on, and so there's likely to be more issues there. The early releases of a product, you have higher likelihood of problems. So the more we can get ahead of that, the more satisfied the customer will be. Shifting that to tens of thousands, there's a very high expectation where there's a significant amount of removal between the company and the customer. So they just go to Best Buy and they go buy it, right? Something like that. And they expect it to just work. There's no, if they have to interact with customer service, that's friction. And that's a half a point to a star rating drop on your Amazon score every time they have to do that. And so anything you can do to harden the product so that it will work right off the bat is really important. And stuff like SimpliSafe, we're talking about compatibility with every home network, every Wi-Fi router, every home configuration, no RF noise in the space. There's so many different variables, and that's where testing and developing for all those variables becomes super, super important.
How big's the team at SimpliSafe, or was it when you were there? Because that's a really impressive product. I've always said they've had the most insane onboarding experience. It's like much easier to install a SimpliSafe security than to even call the ADT guy yourself.
Yeah, well, I got the engineering team wise, we had maybe on the order of 20 or so hardware engineers, and I think maybe about 30 or 40 embedded software engineers, and then just general software is another couple hundred. It's so that's a pretty substantial team.
And then Volta, what's the team like there?
Well, Volta, we're at like 38 folks now.
Okay,
so hardware engineering is pretty small.
But and then how many are on your team on the hardware side?
I think we're about 7 or 8 folks. So a mix of software, SQA, electrical, and mechanical.
And are you doing much robotics in this stack? Is that part of the application? I guess I would assume you're moving things around, right?
Yeah. So it's as one of our engineers, he would call it a robot without legs. But it's similar to a 3D printer. So it's a fluidics gantry, and so that's where a lot of the movement comes in. But we have some other dynamic moving parts where there's vibration, there's heating, there's active cooling. So like with the thermoelectric Peltier device type of thing. So it depends on how you define robotics. Some folks would define robotics only something that like really needs kind of like pretty sophisticated feedback control with a Simulink type of, the MATLAB Simulink kind of simulations for really like sophisticated development. We're not really doing anything that sophisticated, but it is relatively high precision on the order of microliters of fluidics manipulation and accuracy that we have to achieve.
Are you guys using ROS for anything there, or are you just programming these controllers directly?
Yeah, just programming everything directly. So we do have an embedded Linux single board computer that is kind of the brains that's distributed out to motor controllers and other embedded custom boards with with microcontrollers on them. So good mix of languages: C, C++, Rust, Python, all embedded within one product.
And how long have you been in Boston?
I've been in Boston area for quite a while. So early in my career, I moved to Seattle to work at. I wound up working at Microsoft out there for a few years, and I moved back to Boston in 2006 or so. And so I think I've been mostly in Boston since, but I spent about 2 years in Portland at Nike.
Okay.
But yeah, other than that, I went to UMass Amherst, so I've been in the Boston area, Massachusetts area for quite a while now.
Boston's amazing. Every time I go there, I'm just impressed with how many, like I'm in Nashville. We have a lot of young people in Nashville, but they're in like cowboy boots and half of them are drunk. And then when I go to Boston, there's just as many young people, but they're all so serious. Like it's very like career, academic, like just very, very focused general population.
Yeah, it's definitely a type A vibe out here.
Yeah.
A lot of incredibly smart people, incredibly smart. Like the things that people talk about, just like at parties, just like the incredible things they're talking about. It's pretty inspiring. I just went to a random robotics meetup, and there's the AI Institute out here, which branched out of Boston Dynamics. And they're just talking about random robot projects they're working on. They don't have any specific applications, but it's super interesting, and it's pretty phenomenal what's going on.
Are there any companies up there you think are set to take off aside from Volta?
I know of Leaf Labs and NK Labs. They're kind of in a similar space, but they've done some amazing things in the past. Both of those labs, for example.
Yeah, it's really interesting with all the research up there and just the general focus on commercialization of the research code. You don't always see that, folks who are like just good tech transfer. We have a bit of that in Tennessee at Oak Ridge and UTK Knoxville, but I don't think it's been as successful. It seems like it stays more defense oriented or research like towards the labs. And it's nice to see such a focus between Harvard and MIT and getting the technology out and like a culture of entrepreneurship within the research organizations themselves.
Yeah. Just thinking back at some other companies. Thinking back at Whoop. So there's some other wearable companies. So there's one called Nix Biosensors, which is a hydration meter, and it's been around for a while, and it feels like they're really picking up steam and about to really blow it up, I think.
And what are they? So is it like ag tech or wearables? You said?
It's a patch you wear device, and it monitors your hydration. So it's also designed for sport athletes. Yeah.
And so you've done some of the wearable stuff. Like where do you feel like you're most comfortable in your hardware experience? Do you like the high volume consumer electronics space? Like I know this is a very different scale, but what's been the most fun for you?
Yeah. So in my career, I've done military stuff. I worked at a periscope company here in Boston. I worked at high volume
periscopes.
Yeah, optronic periscopes. So a full console with all screens and things like that, and camera-based periscope on the top. I worked at a design firm called Continuum, where we worked on a ton of different products and medical products and laboratory products. And then, the high-volume wearable and IoT. I would say what I enjoyed the most was the type of product I'm working on now, which is a complicated kind of electromechanical kind of laboratory style or medical device. I really love the multidisciplinary action aspect of these products. I worked in wearables for 10 years, and after a certain point, I said to myself, there's not a single dynamic moving mechanical part in here, and it just felt like I was missing something. And I'm like,
just sensors and hardening sensors and battery life.
Right. It's just make it smaller, embed more sensors, increase battery life, which are all really tough challenges, right? The more sensors you put in there, the more power consumption you have, and the more connectivity you need, the more power consumption you have, right? And it's also a great engineering challenge, but getting back into things with like a Shark Ninja robot vacuum that has dynamic moving parts, where these things have to work in every home across America, and just really integrating engineering design for robustness and for like complicated environments and complicated tasks. It's so much more fun.
And what about the difference that comes to mind for me in a kind of an operating system perspective, but Linux versus microcontroller? You guys are clearly Linux now, but you get a lot more capabilities there. So, have you always been in embedded Linux space, or is that more recent?
It's from a professional perspective, it's more recent. So, when I started off my career, the periscopes I worked on were running on something called VxWorks, it was a sort of a positive. It's a real-time kernel, a real-time operating system, and it has some POSIX like kind of interfaces, but it's not Linux, right? And I've worked in I've done some projects with QNX, which is another real-time operating system.
Where were you doing QNX?
That was at Continuum.
Okay.
So we
it's heavy in automotive right now. That's like their main.
Right. Yeah. And that was primarily for a medical style product. QNX it meets a lot of regulatory needs. And so it is, if you're going to look for a real time POSIX style kind of operating system, it was a good application at the time. But this was, 2008, 2009. It was quite a while ago.
Did you know they're owned by BlackBerry now?
I know. Yeah. So they're owned by RIM. It's awesome. It's a pretty interesting combo between those two companies now. Yeah, QNX is it's a neat operating system, and I know even ROS has been ported to it. It's one of the few, if not the only, like real RTOSes that ROS I think runs on, if I'm not mistaken. But yeah, then I took a huge gap. Huge part of my career was all microcontrollers, like embedded C. When I did real work as a developer, it was all C. And then at some point moving up, going from 8051s to DS PICs, to, PIC16s to DS PICs to MSP 430s, and to ARM Cortex style processors. I thought it was amazing that we could actually run C++ on these devices at some point. And so there was a huge part of my career. Right. Now we're running Python. You've got Python running in these embedded environments. And so yeah, embedded Linux in a professional environment is relatively new for me. I've been using Raspberry Pis and using Linux for a while in my career now. And when I was in college, I used VSD a lot, FreeBSD. Yeah, it's pretty fun to learn the nuances on how to apply Linux in a robust way. Because there's so many ways to skin the same cat in Linux, and so doing things in a robust way, in a repeatable way, is a big challenge, especially when you have a lot of folks who are not super experienced in it.
Yeah. So what's working for you guys, or what can you share even? Yeah.
I guess what works is the fact that when you have Linux and you've got a popular distribution that has a lot of supporting libraries and a lot of supporting infrastructure, that's what really, really works, and that works really well. So your ability to leverage those libraries and trust those libraries works really well. I think the bigger challenges are things like locking down what version of every app you're using. So if you're gonna making sure that your system is not doing auto updates to versions that you haven't tested, right? Things like that. That's where it gets challenging. But overall, it's the flexibility with using things like Python is massive when it comes to your ability to recruit great talent, because embedded C++ in real-time environments is much more challenging to hire for also.
You guys are not using Yocto-based distributions?
No, not right.
Or any desire to go that route?
I think we absolutely would. I think there's the fact that we're also small and just trying to get the product to work as good as possible, and then we'll move on to the next phase to kind of re-architecting kind of from the operating system up.
Yeah, we're big fans of Yocto, but also acknowledge the really steep learning curve, and it does especially for like robotics people that don't have experience. Robotics people that are not embedded Linux people, which is 99% of them, they're like, I just don't want to. I've spent my whole life learning this other thing. I don't need to have a third career now called Yocto, but it is important at some point. Yeah.
Yeah, and I think that's where you have to strategically build a team with the right skill sets, right? Like think about how you're going to build a team with some folks that are going to be in the DevOps world, some folks who are going to do the deeper robotics, some folks who are going to do the real time kind of like asynchronous architecture, some folks are going to maintain the operating system and the deployment there, and that's just it's a really really important aspect of hiring the right folks for on your team to maintain that, because if you don't have the right OS and you don't have the right kernel and you're not managing it correctly, everything will just fall apart.
How many units do you think you'd get to before you were really needing something like that? Just in general, like when does like a desktop grade OS and like what you're talking about, the Ubuntu, like become challenging to manage at scale? And you're like, okay, I've got 1,000 units, I've got 10,000, I can manage this, or is it like more like dozens to hundreds?
Oh, I think once you get to 50 to 100, once you get beyond that, just managing with a desktop style operating system will totally fall apart. Will become unmanageable.
Yeah, it's hard. You mentioned the robotics startups. Is that where you look for a lot of your talent, or like when you're hiring, what do you look for in the current setup?
I guess with hiring, we're looking. I specifically look for like 4 kind of primary categories: the ability to get things done, the ability to communicate, cultural fit, technical capabilities. And so when it comes to technical capabilities, you don't have to come from a robotics background, but coming in with a strong, deep capability in something that is going to be valuable to the organization, and having proving yourself in the interview process that you can learn what is needed to be learned for to be successful at the company.
So obviously some that are more like the biologist background that are now on the hardware team.
We have a few folks that we call them systems integrations engineers, and they're like really talented, like cross-disciplinary folks that can go from fluidics to biology and write software. And sometimes on the software team, we're like, hey, why don't you come join the software team? But they're, and they're like, well, no, I got to go play with some fluidics. I don't have time to just write a bunch of code. So there are some folks who can really span those gaps, but then we have also plenty of folks who just like are deep in the software, deep in the Linux, deep in the Python, and deep in the architecture, deep in firmware, because we have a few custom boards with firmware. You also need that stratification of folks who are deep in certain areas that they can hold up the fort in those areas, and then you have the other folks who can kind of span the gap and kind of be cross-disciplinary and kind of go where they're needed.
What is a fluidics person?
It's largely somebody who has a little bit more of a mechanical background and kind of understands the dynamics of how fluidics work, especially like in these tiny microliter kind of environments. So if you want to,
these people in Nashville, I've never heard of that. The fluidics concentration. Yeah.
If you want to pick up a droplet that is 25 microliters, or if you want to deposit a droplet that is 25 microliters and you want it to always be 25 microliters plus or minus 1 microliter, you need somebody who kind of knows what they're doing when it comes to making sure that works.
What is that? What are the tools? Like, what does that look like? It's really interesting. Like, is it? Yeah. How do you?
Well, fortunately,
yeah.
So fortunately, we use an off-the-shelf diaphragm pipettor or displacement pipettor. I forgot what ADP. Automated displacement or diaphragm type pipettor. So that's an off-the-shelf product, fortunately.
Okay.
But, so there are some super smart people who developed that product from a company called TCAN, and we integrate that in, but it's still not everything. Just because they have a lot of certain amount of accuracy within their system doesn't mean we're using it correctly. Right, and so that's where it comes into, like, we're integrating it correctly. So
this is like other life sciences equipment that you're wrapping around, bundling into your solution.
Right. So this pipettor is something we'll put on the gantry, and it'll move all around. And when we bring it to pick up a couple microliters of blood, it'll come down, it'll go into a vial of blood, and it'll suck up the blood, and then move it to another location, and then drop it down. And so that's an off-the-shelf pipettor device that we'll put on the gantry. So accuracy of the gantry. So it is quite important for our system. And so it can't drift over time, things like that.
Yeah, I remember reading the Theranos book and just being blown away by, not that you guys are Theranos, I'm not implying that at all, but like just how they were trying to glaze over, and they were like pushing the timelines and pressure and all this, and they were like, this is so specific, so surgical, and yeah, I have very little experience in the life sciences world. It's really cool.
It is very specific, and it is very surgical, but... Yeah, and I've read Bad Blood. It's an awesome book. It's the one not
tech thriller.
Yeah.
What are you excited about? What's next for you guys?
For Volta, I'm certainly excited about the next phase of really expanding our deployment, getting more customers. One thing I learned when I was at Nike was just interacting with customers is really interesting, really valuable, and so. As we get more customers and hearing their feedback and taking that feedback and turning it into actionable design changes or improvements, that gets really exciting. And I really personally get excited about creating product that people love and love to use. And when I was at Nike, I worked on the fuel band, and the early launch of the fuel band was a little rocky, and so I flew to the call center and just listened to customers. And the technical problems that they were having, I would just listen on the phone, or I would actively try to debug with them. And it was so eye-opening when it comes for me as an engineer to really interact with the customer. So I'm really, really looking forward to just getting more product out there and getting more folks using it.
Nice.
Yeah.
Well, any way we can help you guys? Anything the show can do? We got you guys hiring? You looking for? I don't have a huge following in the life sciences space, so we do know a lot of robotics people.
Yeah, so we do have a couple of roles open. We're looking for a director of manufacturing. I have an electrical engineer role open, and I think we have a couple of marketing roles open. So certainly would love to, if anybody's interested, reach out.
What's the director of manufacturing? So were you guys doing tell me a little bit more about that role.
So we... Yeah, do you want to jump?
No, that would not be a good fit for me personally.
We manufacture in-house, which is pretty cool. It's pretty awesome to be able to have the engineers and the manufacturing team working together really, really tight. And so that role is to have somebody come in and work with the current manufacturing team and help identify the pain points, the areas of improvement, and really help us scale. To figure out how we can produce more units, because knock on wood, we're hoping that as things look, we'll probably be behind on production compared to what the customer demand might be. So we really want to scale that up.
Nice. Well, awesome. Well, thanks for coming on, Mike. It's good to reconnect. Best of luck with Volta. And if there's any way we can help you out in the future, please let us know. And I would love to have you back on in another year or so and hear about the success and how this director of manufacturing, let you guys, beat the timelines and all the crazy orders you're going to have coming on soon.
Yeah. Well, thanks so much for having me, Bill. This was really fun.
All right, everybody. Just a quick reminder, this podcast is presented by Peridio, the ecosystem for building and maintaining advanced embedded products.